Ask an architect starting a new project today which identity protocol they reach for, and OpenID Connect is almost always the answer. Token-based, JSON, built directly on OAuth 2.0, which is exactly what the last episode covered. Ask that same architect why their company's single biggest enterprise contract still authenticates through an XML-based protocol that predates OIDC by the better part of a decade. And you'll usually get a slightly embarrassed pause before the honest answer, because the customer's own IT department insisted on it, and the customer is worth too much revenue to argue with. That protocol is SAML, it is nowhere near dead, and understanding why it refuses to disappear, plus how to run it alongside something newer without your architecture collapsing into a pile of one-off integrations, is what this episode is actually about. SAML stands for Security Assertion Markup Language. It's an OASIS standard now in its second major version, and it predates OAuth 2.0 and OpenID Connect by roughly a decade. That age explains almost everything about how the protocol is shaped. SAML was built to solve one specific, narrower problem than the one OIDC eventually solved. Single sign-on into browser-based enterprise web applications, full stop. Not delegated API access, not mobile app authentication, not machine-to-machine calls. A human in a browser signing into a corporate web app without typing a second password. The model it uses is assertion-based, and it's the thing that differs most sharply from what OIDC does later. An identity provider, the system that actually knows who the user is, authenticates the user directly, then produces a signed XML document called an assertion, containing an authentication statement saying this person was verified at this time using this method, plus typically one or more attribute statements carrying things like an email address, a department, or a role. The document is signed with the identity provider's private key using XML digital signature, and it travels to the application entirely through the user's browser. There's no separate backchannel call to the identity provider during the login itself. The browser carries the assertion. The application's only job is to check the signature against a certificate it already trusts, and if that checks out, it trusts everything the assertion says. That's the whole model. One signed document, browser delivered, containing a complete claim about who this person is. It's a reasonable design for the problem it was built for, and one with no real concept of a bearer token meant for an API, a refresh cycle, or a mobile client that isn't running inside a full browser, because none of those were the problems SAML was written to solve. Put the two protocols' actual documents side by side, and the difference stops being abstract. A SAML assertion is XML, an authentication statement and an attribute statement, wrapped in a signed envelope, delivered to the application's assertion consumer service URL via an HTTP post from the user's browser. An OIDC ID token is a JWT, 3 base 64 URL encoded segments, header, payload, and signature, carrying claims like subject, issuer, audience, and expiry, and it doesn't arrive by browser post at all. It's fetched by the client application from the identity provider's token endpoint, over a direct back-channel call, after an authorization code, round trip, the exact mechanism the previous episode walked through against RFC 6749, and the OpenID Connect course specification. One is a document the browser hands you. The other is a token you go and collect yourself, over a channel the browser never sees. SAML also has two distinct ways a login can start, and the difference matters. In SP-initiated flow, the user opens the application directly. The application notices they're not authenticated and redirects them to the identity provider, carrying an author request naming exactly which application and callback URL this login is for. The identity provider authenticates the user, then redirects back with an assertion targeted at that request. In IdP-initiated flow, there's no prior request at all. The user starts at the identity provider itself, or a company portal it powers, clicks a tile for the application, and the identity provider generates an assertion and posts it to the application unprompted. IdP-initiated flow is convenient for end users, and it's also the flow that requires the most careful defensive engineering on the receiving end, because there's no original request to match the assertion against, which is why real implementations have to validate audience restriction and enforce a one-time use identifier on every assertion they accept, rather than trusting that a signed document arriving unprompted is automatically safe. Before any of this can run, there's a handshake. Neither protocol lets you skip. The identity provider and the application must establish mutual trust in advance. In SAML, that's a metadata exchange. Each side publishes an XML document naming its entity ID, its endpoints, and the certificate the other side should use to validate signatures. And an administrator on each side typically loads the other's metadata by hand or through a semi-automated exchange. OIDC's version is lighter weight, a discovery document at a well-known URL, plus, in many deployments, dynamic client registration that doesn't require a human to manually swap XML files at all. Neither approach is wrong. They're built for different eras of how much automation you could assume between two organizations that had never talked to each other before. None of this explains why a protocol built for an older problem is still load-bearing in current enterprise architecture. Two reasons actually hold up. The first is legacy enterprise software. A meaningful share of the SaaS products large enterprises depend on, HR platforms, ERP systems, older CRM deployments, were built in an era when SAML was simply the standard, and many still only support SAML for single sign-on today. Swapping the identity layer underneath a live, multi-tenant enterprise product is a large, genuinely risky migration, and it's rarely at the top of a vendor's roadmap, while the existing integration keeps working fine for the customers already on it. That's not laziness, it's a rational prioritization decision, repeated across enough vendors that SAML-only SSO remains common rather than rare. The second reason is more structural, and it's the one that drives the architecture problem. This episode is built around B2B and partner federation, where the identity source of truth isn't the vendor, it's the customer. When a large enterprise customer's own IT and security team has already standardized, company-wide, on SAML for every third-party application it federates into, the vendor selling into that customer doesn't get a vote. The customer's identity team isn't going to re-architect years of internal tooling, policy, and audit process to suit one vendor's protocol preference, no matter how modern. If you want that customer's business, you support the protocol their identity team already runs, which means keeping SAML alive is frequently a procurement and trust reality dressed up as a technical one. And architects who treat it as purely technical tend to lose the argument with their own sales team. This is exactly the situation Kestrel's architects walked into once the rebuild from earlier in this arc landed. Internally, Kestrel is now OIDC native end-to-end. Every internal service call carries an OIDC-issued token, checked at the policy enforcement point the Zero Trust redesign built, and nothing inside that boundary speaks anything else. That part of the story is finished. What isn't finished is the edge facing Kestrel's actual customers. Kestrel's platform is used across hospital system partners and insurance payer partners, and several of the largest are themselves sizable enterprises running their own long-established identity infrastructure. Their security policy on this point isn't a preference, it's a mandate. Any third-party application their staff use, including Kestrel's, accepts single sign-on from their identity provider via SAML, full stop, no exceptions negotiated for one vendor. So Kestrel's architects are holding two true statements at once. Internal services just finished standardizing on OIDC, and the revenue-critical partner edge is contractually required to speak the older protocol those internal services were never built to understand. The tempting shortcuts both fail for reasons the earlier scenes already set up. Hand-rolling SAML validation directly inside the customer-facing application, one bespoke integration per hospital system, doesn't scale. Every new partner becomes its own sub-project, and every partner's quirks, different attribute names, signing certificates, assertion lifetimes, leak straight into application code that was only ever supposed to answer one question: is this user authenticated? Ripping out the OIDC rebuild to unify everything on SAML instead is worse. A direct regression against the whole point of the Zero Trust redesign. And SAML's browser-only model has no clean answer for internal service-to-service calls or the API and mobile clients already on Kestrel's roadmap. The pattern that resolves this doesn't ask either side to change. It inserts a third component between them, an identity broker, sometimes called a federation gateway, whose entire job is protocol translation. Every partner's identity provider federates into the broker using SAML, exactly the way its IT department already requires. The broker validates each partner's assertion, extracts the identity it describes, and issues its own OIDC tokens, an ID token and an access token, to Kestrel's actual application backend. The application itself never touches SAML. It implements exactly one identity integration, OIDC, against the broker, and the broker absorbs every partner-specific quirk on the other side of that boundary. This is precisely the role played in production by commercial identity platforms like Okta and Auth0, and by the open-source equivalent, Keycloak, which can operate as both a SAML identity provider or service provider and an OIDC provider simultaneously, translating between whichever protocol a partner brings and whichever protocol the internal application understands. The specific product is a build versus buy decision each organization makes on its own terms. The architectural shape is the same regardless. Partner protocol diversity gets absorbed at one boundary, and everything behind it, all of Kestrel's application code, only ever has to reason about a single internal identity format. The practical payoff shows up the next time Kestrel signs a new hospital system partner. Onboarding partner number 9 doesn't touch a single line of application code. It's a new SAML connection profile configured on the broker, a certificate, an entity ID, a couple of endpoints, and partner 9's users are live. The application was never involved because it was never supposed to be. A handful of mistakes recur often enough to name directly. The first is exactly the shortcut Kestrel's team nearly took, handling one partner's SAML integration as a one-off directly inside application code because the broker wasn't in place yet and the deadline was close. It works for one partner. It becomes unmaintainable by the third. The second is trusting IdP-initiated SSO without the specific defensive checks it requires, validating audience restriction so an assertion issued for one application can't be replayed against another, and enforcing a one-time use identifier so the same signed assertion can't be replayed a second time by anyone who intercepts it. IdP-initiated flow is convenient precisely because there's no prior request to check the assertion against, which is exactly why skipping those checks is so easy to get away with until the day it isn't. The third is forgetting that SAML signing certificates expire on each partner's own rotation schedule, not yours. And a lapsed certificate silently locks out an entire partner's user base until someone notices support tickets climbing. A genuinely boring operational detail that has caused real outages at organizations far more careful than that sounds. The fourth is assuming federation is federation, and mapping a SAML assertion's attributes onto internal roles using the same logic built for OIDC claims. The two protocols' identity models don't line up one-to-one. SAML's name ID format carries its own quirks, and OIDC's stable subject claim doesn't have a direct equivalent inside every SAML assertion. Building that mapping logic once correctly inside the broker is exactly the kind of detail this whole pattern exists to contain in one place instead of scattering it across every partner integration. SAML and OIDC both answer the same underlying question: is this human who they claim to be? For two different eras of how applications get built, and a federation gateway lets a real enterprise estate run both at once without either protocol contaminating the other side of the boundary. But there's a completely different identity problem sitting just behind that gateway that neither protocol touches at all: how the services behind it prove who they are to each other, continuously, without a login screen, without a human anywhere in the loop, and ideally without a long-lived static credential either. That's spiffy and spire, cryptographic workload identity that replaces the IP address as the thing services use to trust each other. That's next episode. If you're building an identity architecture that has to survive contact with a real, messy, multi-protocol enterprise estate, not just the clean greenfield diagram, subscribe and I'll see you in the next one.